Hello, ladies and gentlemen. I'm Mr. White. This is Lesson 12-8, Compound Events. We're going to look at the probability of some event happening, or actually, when we use compound, we're going to look at two or more events being connected by words with and or. Okay, so when two events have no outcomes in common, these events are mutually exclusive. Event A, like musical players, and we have B, students that play sports. Okay, what we're saying when these are mutually exclusive, we're saying that there are these musical students that don't play sports, or there are these sports students that don't play a musical instrument. When we have mutually inclusive, or when the events have something that's in common, okay, then we have this overlap, and then we get this middle here, which becomes the inclusive part. Okay, then this is the probability of A and B occurring. So we will need to determine whether two events A and B are mutually exclusive before we actually find the probability of A or B. Okay, so we're going to look at the probability of A or B first. All right, so if we're going to look at the probability of mutually exclusive events, or if A and B, like the blue circles, if those events are separate and there is nothing that's in common, what we can say is they are mutually exclusive if the probability of A or B is equal to, and then we take the probability of A and just add it to the probability of B occurring. If we have, taking my blue circles now, if we have overlapping events, then what we have to do is we say the probability of A or B in green is equal to the probability of A plus the probability of B, and then we have to subtract that middle green part, which is the probability of A and B. So problem number 1. Suppose you spin a spinner that has 20 equal size sections, numbered from 1 to 20. So what we want is we want the probability that you spin a 2 or a 5. So the first thing what we need to do is we need to write down, we're going to take the probability of a 2 or a 5. So we need to look at the sample space of how many 2's are on this spinner and how many 5's are on this spinner. So when we're looking at the probability of 2 or 5, we need to first ask ourselves, are these mutually exclusive? In other words, is the 2 separate from the 5? If you spin a 2, can that 2 represent a 5? And the answer is no. So if that's no, then we know that these are mutually exclusive. And if they're mutually exclusive, what we're going to do is we're going to take the probability that we have a 2 and add that to the probability that we have a 5. So we know that there's 1 2 out of 20 on a die, so it's the probability of 1 out of 20, plus the same thing with the 5, 1 out of 20. If we add those together, we get 2 20s, or we always want to reduce to 1/10. All right, B. What is the probability that you spin a number that is a multiple of 2 or 5? So we're going to write probability and then multiple of 2 or 5. So what we have to do is we have to think of the sample space between the multiples of 2, and then we're going to have the multiples of 5 on this spinner. So we can start with the first one, 2. We're going to have 2. Then 2 times 2 is 4, 6, basically all the evens, 8, 10, 12, 14, 16, 18, and 20. Now if we look at multiples of 5, we have 5 times 1 is 5, and then we have 10, 15, and 20. So if these are mutually exclusive, there are no multiples of 2's over here in the multiples of 5. And if they aren't, then there is. And so for instance, if we look at this, we can see, so 5, 15, and 20, we know that 10 and 20 are 10 and 20 over here. So 2 and 5, there are numbers that are multiples of 2 and also a multiple of 5. So that means that these are not mutually exclusive. So what we have to do now is we take the probability of the multiple of 2 plus the probability of multiples of 5, but then we have to subtract the probability of them both. So the 2 and the 5, or the multiples of 2 and 5. So doing the first one, the probability that we got multiples of 2, there were 10 out of the 20 on the spinner, plus there were 4 out of 20. And the reason why we're minusing also is we do not want to recount. So if we just count all these multiples, we have 10 plus the 4, that's 14. But if you notice, I counted the circled ones twice. So we have to subtract the 2 that are like. So when we add 10 plus 4 minus 2, we're going to get 12 20s, which also reduces to 3/5. So there's a 3/5 probability of getting a multiple of 2 or 5. All right, on the got it. We're going to suppose you roll a standard number cube, which means has a 1, 2, 3, 4, 5, or 6 on there. Okay, for A, what is the probability that you roll an even number or a number less than 4? And then B, what is the probability that you roll a 2 or an odd number? Go ahead, hit pause, and check with us in a few minutes. Go. All right, welcome back. If you look at what is the probability that you roll an even number or a number less than 4? So we had to first figure out if these are mutually exclusive. Okay, here is our, in red on the far left, here is our even rolls, 2, 4, and 6. Here is our numbers if we roll it less than 4, 1, 2, 3. So what we need to look at is there anything in both of those? And we see that there is a 2. Therefore, they're not mutually exclusive. They're not separate. So now we go the probability for the formula of even plus the probability of the numbers less than 4 minus that probability of even and number less than 4. So there were 3 out of 6 that were probably of even. We had 3 out of 6 that were numbers less than 4 minus the one answer, 2 out of the 6, gives us 5, 6. Okay. On B, we wanted to find the probability that you roll a 2 or an odd number. A 2 is not an odd, so they are mutually exclusive. So we just take the probability of 2 and add it to the probability of getting an odd. We take the probability of 2 and add it to the probability of getting an odd. So 1 plus 3 gives us 4. 4, 6 is equal to 2/3. All right, practice time. Okay, if we look at 12-8 practice, okay, well, let's do a couple together and then we'll turn you loose. If we look at number 5, again, suppose we have that spinner and it has 12 equal size sections numbered 1 to 12. We need to find the probability of each. Remember that we don't want to count things twice. So on 5, it's the probability of odd or a multiple of 5. So we have this section over here that's odd, and we have the spinner is 1 to 12. So if there's 12 numbers, we have 6 of them, okay, or 1, 3, 5, 7, 9, 11. So 6 answers that are odd. And then multiples of 5, if you draw this, 5, 10, and that's going to be it. So we have to look at, are these mutually exclusive? And you should see that there is a 5 in both. So they are not mutually exclusive. So our formula is going to be the probability of odd plus the multiples of 5 minus the probability of both. So the probability of getting an odd number is 6 out of 12 numbers plus the probability of the 5 and the 10, which is 2 out of 12, minus the 1 overlap, 1 out of 12, gives us 6 plus 2 minus 1, gives us 7 twelfths. All right, let's back up 1 to number 4. Probability of a multiple of 3 or odd. So again, we have this just quick sample space to look at. Multiples of 3 would be 3 times 1 is 3, 6, 9, and 12. And then we have odd again, which is our 1, 3, 5, 7, 9, and 11. Okay, do we have any overlap? Well, we can see that we have a 3, we have a 9, and that's it. So we actually have 2. So these are not mutually exclusive. So we're going to say we need the probability of a multiple of 3 plus the probability of odd minus the probability of multiple of 3 and odd. So the multiples of 3, there were 4, 3, 6, 9, and 12. So we have 4 out of the 12. We have 6 odd. So plus the 6 out of 12 odd minus the 2 overlap. So minus 2 over 12. We're going to get 4 plus 6 is 10 minus 2 gives us 8 twelfths. And then we always want to reduce. 4 goes into both and it leaves 2/3. So there is a 2/3 chance of getting a multiple of 3 or odd. All right, let's flip over. The other way we can do probability. So we have mutually exclusive, the probability of or. What if this is the probability of and? Okay, now we need both on 12 through 17. And like number 11, because you need both free throws. So you choose a marble at random from a bag containing 3 blue marbles, 5 red marbles, and 2 green marbles. You replace the marble, put it back in. Okay, then choose again. Find the probability of each. What we're doing is we're trying to find out, does my probability change or does it stay the same? Is it independent or dependent? So what we want to pay particular attention to is this replacing the marble. Okay, if we take a marble out and put it back in, we are back to the same denominator that we originally started with. Okay, this makes 2 events independent. So we have 3, 5, and 2, 8, and 10. We have 10 marbles to start. Okay, so if we want both blue, if these are independent events, okay, underneath 12, we're going to take the probability of A and, so now we're looking at the and. If they're independent, then we're going to take the probability of A times the probability of B. If they are dependent and we do not replace, we take the probability of A and B, it's the probability of A times the probability of B slash A, meaning it's the probability of B given that A occurred. So let's just take the first one. The probability of both blue. So we want a blue marble. Okay, so there are 3 blue marbles. We have a 3/10 chance of getting a blue marble. Okay, so we get a blue marble. We take out the blue marble, there's 3/10. Okay, if we put the blue marble back in, how many marbles are left? Well, now it's back to 10. And what is the chances of now choosing another blue marble? Well, we still have 3 in there. So we have 3/10 times 3/10, which is 9/100. What's the probability that you choose a blue, then a green? Okay. This then is just like an and, so we're still saying a blue and a green. Because we are still replacing a marble, these are independent events, so the probability of choosing a blue marble was again still 3/10. So we take a marble out. There are now 9 marbles in there. We put the marble back. Okay. What's the probability of now choosing a green? Well, there's 2 green, and there were 10 marbles in there, so the answer is 3/10 times 2/10, which is 6/100. Reduce to 2/50. 18 through 23. Now, if we do not replace something without replacement, now we are looking at dependent events happening. So we have a tile from a bag that's 2 tiles is X, 6 tiles is Y, and 4 tiles is Z. So we have 12 total tiles. What's the probability that we draw tile X and then draw tile Y? And this is without replacing that first tile. Because these are dependent events, our formula states that we're going to take the probability of X times the probability of Y given that X occurred. Or what's the probability of drawing an X tile? We have 2 out of 12. We have a tile out. We drew that X tile. Now how many tiles do we have? Well, there are only 11 now. So now what is the probability that you choose a Y tile? Well, there are 6 Y tiles, but there's only 11, so the answer is 6/11. So 2/12 times 6/11 gives us 12 out of 132, or 2 times 6 is 12, 12's cancel, and you have 1/11. Let's do one more, number 22. Both Z. So what's the probability that we choose a Z tile first? There are 4 Z tiles. So 4 out of 12 times. Now remember, we took a tile out. Okay, so what? And it is a Z tile. So what's the probability that we now draw another Z tile? Well, there's only 11 in there, and we already drew 1 Z tile out. So therefore, there are only 3 left. 4 times 3 is 12. There's a 12 on the bottom, so we can cancel, and the answer is 1/11. Or again, 12 over 132, which reduces to 1/11. All right, one more. 23. What's the probability that you draw a Y? There are 6 tiles, so we have 6/12 for the first one, and, meaning multiply, now we want a Z tile. But remember, we did not replace the Y tile. So, how many Z tiles are left? There are still 4 Z tiles, but there's only 11 total. So you have 6/12 times 4/11, which is 24 over 132, or reduces 2 2/11. All right, congratulations. What you want to do is go back to the beginning of this practice, 12.8. Make sure you finish all the problems that we did not do. Continue on to this next page. Finish those problems that we did not do. Be sure to check your answers on the website in the 12-8 section of the chapter. And again, if you have any questions, please see your teacher as soon as possible. Otherwise, don't forget to do your best, forget the rest. Bye for now.